So let's take a look at this problem. This says find the equation of the parabola, 2 points that define the lattice rectum, and graph the equation. So it wants us to do the same 3 things we did with the previous problems. So with this one's a little different here. But what I'm going to do first is I'm just going to graph everything that I have, so I kind of have an understanding of what I'm dealing with here. So this says I go to the left 3 and up 4. So it's going to put me here. So it's going to be my first point. And then it says the directrix is y equals 2. So it's going to put me here. Okay, and then right away, because what I think of is I think of the picture of what this is going to give me. And I know it's opening upward because here's my focus. There it is, and the directrix is down here. And then notice this, that parabola is going to go away from the directrix and towards the focus. So that's how I know it's going to open upward. So I know I'm dealing with an x squared here. So I'm going to label this so I don't mix it up with the vertex. And I also know here that the distance from the focus to the vertex is a, and the distance from the directrix to f is 2a. So I know this here is 2a. So I know that distance is 2. So if I wanted to, I could write 2a equals 2. And if I divide by 2, I get a equals 1. So that's one way of actually calculating your a using algebra. So then my equation is going to be x squared equals 4ay. But there's a little bit of a modification here. Now that I know where the vertex is at, I know my vertex is here because remember it's halfway between the focus and the directrix. Okay, that's my V. And that tells me right there how this graph actually shifts. So in general, if my vertex was 0, 0, then this would be my completed answer, plugging my value in for A. But since this is moving my vertex over, did you guys notice that? Then that means that this is going to come over this way, 3. So that's a -3 there, isn't it? Yep, so how I write that -3 to the left there, or I should say 3 to the left, or -3, that makes that x plus 3 squared. And I've heard people say that, oh, it's the opposite of what I think, or it's the opposite of that. So since that's in a -3, I'm going to write a +3. And I think of it this way, what makes it 0? -3 does. So that's how I know it's in the -3 direction. And then we're going to go up 3. So when going up 3, I have 4a, and since I'm going up, that's going to be a y minus 3. Because what makes that 0? +3, so that means I went up 3. Now this is just a slight modification of what we've done previously, other than the shift. So knowing where the vertex is, we're able to put our shift in. Now this is not quite our complete answer. We got to find our a now. We do know the a is 1 from computing it earlier. So this is really x plus 3 squared equals 4 times 1 is 4. Y minus 3. So there's our first question being answered there. So there's our equation. Okay, now from here we have to find the 2 points that define the lattice rectum. Now that's what we're going to do. Now keep in mind here, now when I'm finding that lattice rectum, I use my focus. My focus is on the same line as those, and I know it's going to go in this direction because it kind of helps define the width of the parabola. At least it shows the width of the parabola. So that's what I'm going to do here. I'm essentially try to find those values now. Now remember, our focus is -3, 4. Okay, so, and I'm going upward here, so that means I'm going to plug in 4 for my y here, because I want to find out where my graph is at y equals 4. So now I'm just going to plug in 4 for my y. So that's going to be an x plus 3 squared equals 4. And then I'm going to plug in the 4 minus 3 there. Okay. And then that's going to be x plus 3 squared. Now I know some of you are thinking that, hey, let me multiply that out on the left there. Don't do that. It's actually a lot easier than that. And this is really just going to be 4 times 1. And then what do I do next? I square root both sides, but let me write this first. X plus 3 squared equals 4, and then I square root both sides. And then I get x equals, not x equals, excuse me. I have more here. X plus 3 equals plus or minus 2. And then to simplify, I subtract x over, so I get negative 3 plus or minus 2, which means x is going to equal negative 1 or negative 5. And my two-ordered pair then, remember I plugged in 4 for y. So it's going to be negative 1, 4 or negative 5, 4. Okay, so those are the answers for part 2. And then I can graph those now. And I just graph those in a blue so you can see where they're at on the graph. Now we're ready to actually complete our graph here. We have everything that we need. So now that's our picture. Now don't forget, we should draw that lattice rectum in there as well. That will be across here. So there's our completed picture for part C.